All right. Well, hopefully you work through this problem and have come up with an answer. I know that one thing I looked at the video I just made on the front part. When you're converting percents into decimals for your calculator, you move two spots to the left. At one point in the video, I misspoke and said two spots to the right. You want to move to the left, or just divide by 100. Either way, you'll be fine. So let's get our highlighter out here and see what the heck they want us to do. Well, they want to find the average atomic mass, which is exactly what we've been doing. And so we want to find the pieces that go together. So we have carbon 12, and it's got a mass of 12.00 and is 98% of what you find in nature. So most carbon that you find is going to be this carbon 12, meaning it's going to weigh 12, right? So that links up with that. Okay, so let's go to the next one. And carbon 13, which weighs 13.003, is 1.5% of what we find out there. And then the rarest type of carbon is this carbon 14. So that's the rarest one. And it is the most unstable, meaning it just doesn't stay around very long. And it weighs 14 and is 0.5%. So we've got these three numbers, same as you just did in the previous example. We're going to take the mass, multiply it by the percentage, and then add them up. So let's start with the 12.00, and let's multiply it by the 98. So this is where I misspoke in the video. You want to move the decimal two spots to the left, or divide by 100. So 98 divided by 100 is going to get us that percentage. So if you move it two spots to the left, you divide by 100, you get the same thing. You're going to get 0.98. And so that's going to be my decimal value for my calculator. Let's go ahead and put that in brackets, meaning we're going to do that first. And let's come over here and do the next part. That's going to be the 13 0.003. We're going to multiply that by the 1.5. So let's see, they go together. Now 1.5 has to again be divided by 100, or you move the decimal two spots to the left, and you're going to get 0.015. So that's going to go here. Calculator value. That's your percent in your calculator. And then we'll go ahead and drop in this last one. And bada boom, bada bing, there we are. We've got a 14. And you can put 14.00, I guess, for the accuracy. You probably need a parenthesis there, so let's go and fix that. 14.00. And then we're going to go ahead and multiply that by this 0.5. So it'd be 0.5 divided by 100. Move the decimal two spots to the left. You're going to get a very small number, which is half of a percent. So fairly insignificant. And then we're going to get an answer. Okay, when you do this in your calculator, make sure that you are using parentheses, that you're doing an order of operations, so your calculator doesn't give you like a ridiculous answer that makes no sense. So what did I say earlier that our answer should? What range should it fall into? It's got to be between the highest value and the lowest value. So let's see where we've got. We've got a 12, a 13, a 14. So it's got to be between 14 and 12. If I get an answer between 14 and 12, then I know that I got it right. So that might be something worth writing down, that our answer should be between the highest and the lowest number because it's an average, right? So it's going to be between the high and low value. That could probably help you out when you're looking at your answer and you're saying, hey, what the heck, is this thing right or wrong? Well, that might help you figure it out. So get your trusty calculator out. I got mine. I'm going to put it in 12.00. I'm going to multiply it by 0.9800. I'm going to hit enter. Okay, got an answer sitting there. So now you're going to hit the plus sign. Now you're going to do inside parentheses, 13.003 times 0.015. Close those parentheses, hit enter. And then you're going to add that number to, in parentheses, 14 or 14.000 times 0.005. And then we're going to go ahead and close that parentheses and hit enter. Now, I did notice one, this is not going to matter to you guys, but this is a tiny mistake right here that I'm going to just fix, but I should maintain those zeros. So this was right here. That was 0.500 divided by 100. So it should look like that. And so this would look like that. You're not going to change your number at all. It's just a little bit more accurate. Anyway, so let's write down what we got. And I've got 12.025045, and that's AMUs or grams per mole. Not the capital G though. I want the lowercase g. All right. What do we think? Is this? Did we make a mistake? Does this answer make sense? Well, the answer is between the values that we were looking at, right? So it's between 12 and the high value, which was 14, right? So that makes some sense. And so then that should be a good answer because it's between 12 and 14. So if we kind of stick with that idea that I talked about earlier, where maybe we just go with decimal places, go with 2 decimal places, because we haven't really talked a lot about sig figs. Let's just go 12.03 based upon this data. Now, if you look on your periodic table, it's not going to say 12.03. It's going to say 12.01. But with our data, we would have got the 12.03. So pretty darn close, just not exactly what the periodic table has. And that's okay. If we looked here on this one was 12.08. Oh, I probably should have rounded that up. Let me go back to this one real quick. These things are going to happen. If you notice, I kind of made a little rounding mistake. So if we're going to keep 2 decimal places, this 5, I should have rounded that up. So let's just say 12.09. So I'm going to fix that real quick. Made a couple mistakes, but that's okay. We caught them. So I'm going to fix that real quick. So that first one, not a big deal, but the 12.09 would be the more accurate answer. And now this one, like I said, we're getting this 12.03, which it's not 100% correct from the correct table, but it is correct with the data that we have right here. So should be good. So what I want you guys to do is go ahead, and I didn't put them on the Jamboard here, but go ahead and work through the other examples on this paper. I think you should be able to manage them. They're